Hey guys, I'm going to be showing how to go through the top sellers on Steam with a web scraper, grab all these different games, grab their tags and any other information we want, and then we can showcase them in Python and analyze the data in a bunch of different ways. Okay, so to get over here, just go to the main page of Steam, browse, and then all charts and stats. In the top left, there's this top sellers page. It only has the top 100, so if you scroll down to the bottom, you can browse more top sellers. This is going to give us the full page, which if you see, we can kind of keep scrolling infinitely down on this page, and that's a good sign. So this is when you look at a page and you can say, okay, I think I can make a web scraper out of this. The way we're going to do that is look at each of these elements, store their rank, and then if I right click inspect, you'll be able to see that each one of these has a href, which is a link, and underneath it is an entire within the HTML DOM or hierarchy, there are these different elements that we can grab. And you can see actually when you hover over, it does have the tags, but we're going to have to actually click through and go on the page per entry to grab these tags because you'll see they only have the tag IDs right here. Okay, so first press the Windows button and type Anaconda prompt after you've installed Miniconda. We're going to make a folder for this. I already have one right here. You can grab the path and then do cd space right click to change directory into that folder. And in here, I'm going to make a new environment globally, but I just want to have this workspace already active. So I'll do conda create -n to make a new conda environment, and I'll just call it Steam Scraper. We're just going to proceed with this and then activate the environment with conda activate, then the name of your environment. Inside of here, we are going to install Jupyter Notebook. It's just called Notebook here. Okay, next I'm going to run Python as a module with -m so that we can use pip and just triple check that we're not using a global version of the pip. We're using the one that's running in this virtual environment. I'll do pip install, and we're going to install pandas, Selenium, and TQDM, and lastly Plotly. So these are going to be our pandas is kind of like Excel. Selenium is our WebDriver. TQDM is just for kind of a progress bar. And then lastly, I like to use Plotly or Seaborn to do my plots and data analysis. Okay, now that that's installed, we'll type Jupyter space notebook. That's Jupyter with a Y. This should launch into your browser. If it doesn't, then just grab this URL and you can paste it into a new browser instance. And what I'll do is just make a file, new notebook. This will be running in our virtual environment. So it's going to have all those packages that are already installed. And inside of here, we're just going to first get our URL. This is not ArcRaiders, it's this one right here. So I did lose it by looking around too much with inspect. Again, you can go to alt charts, top sellers, and then scroll to the very bottom. And there we go. Okay, so this is going to be our base URL. Inside of here, we can get started. It's going to make sure that we're running the right kernel. That's fine. We're already in the Jupyter Notebook from Conda, so we are set. And then lastly, let's check out what's inside of each of these elements. So if I right click one of these, like ArcRaiders inspect, then I should see, again, like I was showing earlier, these kind of, each of these elements inside the HTML DOM. I'll see I can kind of scroll through or slowly hover over each of these, and it's going through the list, this dynamic list on the page. So that's perfect. You can copy any of these just with the right click, copy element down, just right here, copy element, and all Control V to paste it in. So what am I working with? I do have the title, that's perfect. I have the href, which is the link to the main page, and we can grab anything else that we need from the page itself. So I'll just go ahead and continue here. This is not Python, so you could run this with M instead. It'll turn it into Markdown. And then next, let's go ahead and get coding. I'm going to skip this and just explain it after. just so that we don't waste too much time. Okay, here's our code. We have some imports up here, time, pandas, and most importantly, Selenium. We're going to use Selenium to make a new WebDriver with Chrome. And then I have this scroll time that as we're going through this driver, we wait this amount of time in seconds between each scroll. We'll sleep initially just for 2 seconds, just so that we can load up the entire page. And lastly, we're going to keep a record of each of these rows that we're searching using this CSS selector. I would be careful just if your internet is slower or if the pages are taking too long, or sometimes even the resolution of your monitor can change. I tend to err on the safer side, so 0.2, 0.5 is pretty fast. You don't want to miss any elements, so just make this slower. It's better to wait, grab a cup of coffee, than be missing elements and having bad data. So over here, I have a try catch block or try except. Just so that we can exit out and still maintain this data frame, which is based on a series of rows that we're grabbing. Rank is just going to be the number of this element in the list, so 1, 2, 3. And app ID is going to be the Steam page's app ID, of course, title, and then lastly, the Steam URL. The big thing here, again, is that we're using this CSS selector. Span.title was on here. You'll see it's actually going to be inside this HTML code. It's not that important. Just know that if you're writing a different kind of web scraper, all these things are going to change depending on where you would find that. So like span.title for the actual title here is this. It's the class. Span dot just means the class. And you'll find similar things here. Sometimes there's an ID as well, or data variables, just a bunch of HTML stuff here. And then lastly, we're going to execute the script. This is just a tiny little script as a string here, scrolling to the bottom based on the height of the page. All right, let's go ahead and get that running with Shift-Enter. And here we go. This is it running. We should see it wait for just a second or two, and then start scrolling down, waiting 0.5 seconds, and scroll again. So this is perfect. We'll just let this run for a little bit longer. Okay, I'm pretty happy with that amount of data. I'm going to exit out of this. And with this loop, we just need to wait for it to finish. So let's just wait for this star to go away. And there we go. That means it's done executing. We've quit the driver and we've saved it to this data frame. So I can just type df, shift enter. And this is our data frame. We can do .head and 20 if we just want to view the top 20. So these are ranked. One thing to be careful about here, some of these elements that are loaded with Steam's kind of dynamic loading here, especially the ones that are free to play, they're not going to be perfectly in the same order sometimes. So just be careful of that. Again, it can be related to the time sleep, but a lot of the times with the free to play games, Steam kind of loads them in after. So these are going to be relative to the scrolls. So it's totally okay in the grand scheme of things. Just, don't perfectly bet the ranks based on what you get here. But just double checking them real quick. We have Arc Raiders, Steam Deck, Counter-Strike 2 into Battlefield 6 and Warframe into Expedition 33. So that's awesome. Perfect sorting so far. But again, sometimes it will look weird because of the dynamic loading. All right, let's get to the next part. I'll just fast forward to that. Okay, so here we have TQDM. That's our progress bar. Beautiful Soup is kind of like Selenium, but it's a lot faster. We're just going to grab the page directly. So what do we actually need to do? We have our data frame. It has the rank, the app ID, and most importantly right now, the Steam URL. We can go to the Steam URL. It's just like clicking through to the web page. And what I want to grab down here are these tags that are defined. If you inspect, you can see all of them right here. So I just want to grab the ones that are being displayed. And we can do that really easily with Beautiful Soup. So here is how you get it rolling. We're just going to find all tags in that container. Again, if you grab all of this, it's all going to be specific to your DOM or to whatever the structure of your div is. And inside of here, I'm just going to catch the exception just because this stuff, when you're doing web scraping, sometimes you'll find things that have duplicate tags. Just be very careful and always have those try catch blocks. All right, let's run this. And it's just going to take a little bit of time because we don't want to flood this. We could make it multi-threaded, but a lot of the times sites will start to, you know, begin blocking you or not actually give you the data because they're getting overloaded by your IP address. So honestly, for me, I don't mind waiting. If there's a better way, just definitely leave a comment and let me know if I'm doing anything wrong. But this definitely works as a nice, cheap way to do it. Okay, so this has finished. It did take 8 minutes. So again, just if you want that to go a lot faster, you can grab less entries. But I would recommend, you know, being more redundant with this and just double checking everything. So for me, I definitely don't mind waiting on these kind of web scraping projects. So the next thing I'm going to do, let's just check our data frame. Perfect. We do have these tags on each of these, except for, you know, some of them like Steam Deck or the free-to-play games. And if I look at those tags in a list, I can just do all tags equal, and this is that Pythonic list comprehension. We can do tag for tags in df tags, which is our column. And I'll grab a second layer there and just look at all of these together. Okay, so this is all of them merged, and you'll see we have quite a bit if we grab the length of it, like the all tags. We got 7,500. And next, I'm just going to showcase what they are using Plotly. So this is like Seaborn. Plotly is just a visual way that we can have an interactive graph. I highly recommend looking at both. If you want to look, I'm not going to explain all this because it's so in depth and there's so many different options. But just once you have data, the thing I recommend doing is saying, okay, I have my DF or my data frame, and just look at one of the entries, df iloc 0. We'll grab the first row. And you can grab this and kind of search based on it or use AI to help you out. But here's the format of your data. And then you can basically just kind of check Seaborn or check Plotly and see the different galleries of available ways to plot it. Just thinking through, of course, we have a bunch of tags. I just want to see their frequency. So I'm going to grab those and filter out the ones that are kind of in the 1% here, and then just plot them in this Plotly graph, which you can change the height and all that stuff. So just looking at this quickly, single player has the most entries, 277. We go into multiplayer, action, adventure, and these are kind of the very large overused categories that a lot of games will be having. Into simulation, open world, atmospheric. A lot of the indies have online co-op, first person, indie, there it is, RPG, exploration, sandbox. And so all of these is just a really nice way to view the tags in the top list. Again, trying to remember how many we did. We can just check that with df.shape. 507, so the top 507 right now. Again, it's not daily, it changes constantly, so just be careful. And that's the main reason we're doing this, is we can grab these. You could even make a time series per day to look at this. Okay, so one thing I'm curious about with this information or all these stats that we have are the combinations of tags. So for the best games out there, like here, looter shooter and action RPG, if you're an indie dev, that might be something that you want to make. So I want to see those combinations. I'll look at them in pairs. Here is the base code. I'll not go through all this. I'm just going to leave it in the description on the GitHub. But what we're going to do is just grab all the pairs, and let's first display the top 20 pairs by their co-occurrence, just meaning that we have multiplayer and single player together in 169 of these games, and action and single player together in 161. So based on just all the different games that we've collected that are in the top 500 or so, we're looking at multiplayer and single player games. That's huge. That means there's a lot of these games that have both capabilities that are in the top. Action and single player, action and multiplayer. But these are all kind of boring tags. Honestly, for me as an indie dev, I'm more interested in scrolling a little bit down. Atmospheric, people really like to use that, or have games that are single player atmospheric games. Something like Inside would be in that category. Of course, open world adventure and action first persons. Not anything too crazy in here because, again, we're just really looking at co-occurrence. Let me just check the top 20 individual tags themselves. So beyond the obvious ones, simulation is a big one. We have first person into indie, and then survival, and then finally casual, making it into the top 20. Okay, so this one is the average rank ordering up, with of course 1 being the best, and I did filter out the ones that are, just a single occurrence. So there has to be at least 2 games. And I think we can guess which one is strategy superhero. That is Marvel Rivals right here. Hentai, multiplayer, team-based. A lot of these are making their way into the top ranks. We do have isometric Souls-like, which is really cool, but this data is not as informational, I think, for the tags, because you can really just have a game or a few games really skyrocket to the top and dominate this list. So really what I would rather look at is a minimum co-occurrence threshold, meaning like action, adventure, and character customization have to be together at least 10 times. So we're looking at least 10 games for these combinations, which means it's a significant, theme or archetype. And then finally, we'll sort them based on the average rank. So kind of this is the last thing I'll say in the video for the data analysis part. You can definitely go and look at the data on your own, and hopefully it changes, and there's a lot of cool things you can find in it. But here, action choices matter. These average ranks, we want to look at these. They're still pretty large, but that's because we're taking in a very large filtered co-occurrence. So TLDR, we just can take this as the best way, in my opinion, to look at these combinations. So character customization with action adventure, really, really great. A lot of games are doing it, and it's ranking high in the list. Action with choices matter, that's fantastic for indie. Exploration with FPS, that's not one I usually think about, so that's really cool. I guess maybe Rust would classify as that. Adventure Souls-like, those already make sense together. Free to play doesn't really count. Anything else really big in here? Great soundtrack as a third-person game, and then FPS open world. There it is again. So, beautiful single player. A lot of the indies we'll see, they like to be atmospheric or beautiful, things like that. But anyway, I hope you guys got something out of this. I think it's really fun to make, and I really enjoyed doing these kind of things. So just let me know if you want to see more with this. And thank you so much.